Hi everyone. In this video, we are going to discuss about how to calculate probability. So in the previous video, we have discussed what is a random experiment and what are some definitions of probability, such as the classical definition of probability and the statistical definition of probability. So today we are going to discuss the problems that are related to probability using the classical definition of probability. So the classical definition of probability is as follows. If a random experiment or a trial results in n exhaustive, mutually exclusive and equally likely outcomes, that means there are n possible outcomes, out of which m are favorable to the occurrence of an event E, then the probability P is equal to m by n, which is equal to the number of favorable cases divided by the total number of outcomes. So, using this classical definition of probability, we are going to find solutions to some questions. So, the first question is related to the days and year. So, what is the chance that a leap year selected at random will contain 53 Sundays? So, we know in a normal year there is 365 days, and in a leap year there is one more day added to it, which results into 366 days. And we are required to find how many Sundays. So 53, will there be a 53 Sunday? And if there is a 53 Sunday, what is the chance of that in a leap year? So to check how many Sundays are there in a normal year or in a leap year, what we are going to do is we are going to divide 366 by 7, since in each week there is a Sunday. So 366 divided by 7 will give me 52 as the quotient and 2 as a remainder. So there are, in 366 days or in a leap year, there are for sure 52 Sundays. So since 52 Sundays are sure, we need not be bothered about that. There are 2 days left. So that 2 days can have Sundays in it, isn't it? Yes. So we are going to check the possible combinations that can happen in that 2 days, and we know that 2 days are consecutive days. So the possible combinations are, it could be a Sunday Monday, a Monday Tuesday, Tuesday Wednesday, Wednesday Thursday, and Thursday Friday, Friday Saturday, and a Saturday Sunday. So there are 7 possible cases. Those 2 days could be either of these 7 cases. So out of which, in 2 cases there are Sundays. In the first one, which is a Sunday Monday, and in the last one, which is a Saturday Sunday. So those 2 days can be either a Sunday Monday or a Saturday Sunday, for there to be 53 Sundays in a leap year. So out of the 7 possibilities, there are 2 favorable cases. Therefore, the required probability for a leap year to have 53 Sundays is 2 by 7. Now we have a problem based on the dice, based on throwing the dice. That means two unbiased dice are thrown. So an unbiased die is like, it has 6 faces, and on each face it has 1, 2, 3, 4 and 5. That is a normal dice that we use for our games. So if 2 unbiased dice are thrown, we are required to find the probability that both the dice show the same number, the first dice shows 6, and the total of the numbers on the dice is greater than 8. So before going to the probability and before going to find the probabilities of those sub-questions, we are required to find what is the sample space. That means 2 dice are thrown. So the sample space or the possible outcomes could be 1 1 1 2 1 3 etc. up to 6 1 6 2 6 3 6 4 6 5 and 6 6. So if 2 dice are thrown, there are a possibility of these many outcomes. It could be a 5-3, it could be a 6-1, it could be a 6-6, or it could be a 1-1, and it could be any of these 36 possible cases. So if we are throwing 2 dice, the number of possible outcomes, the number of outcomes is 36. Now we are going to find the probabilities. So the first question is to find the probability for both the dice show the same number. So if the both dice shows same number, so if the first die shows a 1, the second die also must show 1. So the first favorable case will be 1 1, next will be 2 2, 3 3, 4 4, 5 5 and 6 6. So the number of favorable cases are 6. And the total number of cases is the number of cases in the sample space, and that is 36. Therefore, the probability is 6 by 36, which is equal to 1 by 6. The next question is find the probability that the first die shows a 6. So there is a restriction that the first die must show only a 6. And it is unrestricted on the second die. So, what it could be? It could be a 6 1, 6 2, 6 3, 6 4, 6 5 and a 6 6. Therefore, the favorable cases are given here, which is 6 1, 6 2, 6 3, 6 4, 6 5 and 6 6. Therefore, here also we have the number of favorable cases are 6. Therefore, the probability will be 6 by 36, which is equal to 1 by 6. Next is to find the probability that the total of the numbers on the dice is greater than 8. The total of numbers on the dice is greater than 8. That is, the sum of numbers that is showing up on the dice must be either a 9 or a 10 or 11 or a 12 or no others. It is only up to 12. Why? Because if we are throwing a die and the die has only 6 faces and the maximum value a die can show is 6. So the sum of numbers on both the dice, if both the dice show 6, then the sum of numbers on the dice will be 12. So the favorable cases are 3 6, 4 5, 4 6, 5 4, 5 5, 5 6, 6 3, 6 4, 6 5, 6 6, etc. So here we have 10 favorable cases and the total number of cases is still the same, and it is 10 by 36, which is equal to 5 by 18. Now what we are going to do? We are going to discuss another problem which is about the playing cards, which is about a deck of cards. Yes, the playing cards. 4 cards are drawn at random from a pack of 52 cards. We are required to find the probability that they are a king, a queen, a jack and an ace. So before going to find the probability, before finding the probability, I'm going to explain what is there in a pack of 52 cards for those who are not familiar with the pack of 52 cards or the pack of playing cards. There are 52 cards in a deck of cards which has 4 symbols in it. A heart, which is red in color, a spade, which is black in color, a diamond, which is again red in color, and a club, which is black in color. So there are 4 shapes, and those 4 shapes, each card is 13 each. 13 each cards in each shape. And The heart and diamond both are red in color, and the club and the spade are black in color. So 13 plus 13, there are 26 black cards and 26 red cards. And in each set, in each symbol, there is a king, there is a queen, there is a jack and an ace. And the rest numbers are 2 to 10. 2, 3, 4, 5, 6, 7, 8, 9 and 10. So, in total there are 13 cards in each shape or in each symbol. So, this is how a set of 52 cards is, or set of playing cards is. Now, we are required to find the probability that if the 4 cards are drawn at random from the pack of 52 cards, we need those 4 cards to be a king, a queen, a jack and an ace. We are required to find what is its probability. So, 4 cards are drawn from a well shuffled pack of 52 cards. So, the combination of those 4 cards could be taken like in 52 C4 ways. So, the total outcome, like in the previous example, the sample space had 36 items or 36 outcomes, 36 possible outcomes. Similarly, for this 4 cards to be chosen from this 52 cards, we have 52 C4 combinations or 52 C4 outcomes. Now, I have already told in each these symbols there is a king, there is a king, there is a queen, there is a jack and there is an ace. So, in total of 52 cards, there are in total 4 kings, 4 queen, 4 jacks and 4 aces. So, one king can be drawn out of these 4 kings, one queen can be drawn out of these 4 queens and one jack can be drawn out of 4 jacks and one ace can be drawn out of 4 aces. So what I have shown here, this image in this slide is the aces and aces in all those 4 symbols. Yes. So the favorable number of cases is 4C1 into 4C1 into 4C1 into 4C1. Why? Because out of those 4 kings of 4 symbols, I just need 1 king. And out of those queens, 4 queens, I just need 1 queen. Similarly, the jack and ace. So I can take that 1 king in 4C1 ways. So 4C1 into 4C2 into 4C1 into 4C1 into 4C1 into 4C1. Hence, the required probability will be the number of favorable cases divided by the total number of cases, and that is here. We know NCX can be solved as n factorial divided by x factorial into n minus x factorial. So, in that way, we can find what is the value of this 4C1 and 52C4 etc. Now we have a similar question that is same as the one we have discussed earlier. So the 4 cards are drawn at random from a pack of 52 cards. So the 4 cards can be drawn from a well shuffled pack of 52 cards in 52 C4 ways, or 52 C4 is the sample space, the number of sample space, or number of outcomes in the sample space. We are required to find the probability that 2 are black and 2 are red. So I have already told there are 26 black cards and 26 red cards, out of which the spade and club are black and the diamond and heart are red. Okay. So there are 26 black cards and 26 red cards in this pack of 52 cards. So the favorable number of cases are 26C2 into 26C2. So hence the required probability will be the number of favorable cases divided by the total number of cases, and that is 26C2 into 26C2 divided by 52C4. I hope this video was useful. Thank you.